Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And, we kind of got everybody back together again and, having a little bit of fun. So, first and foremost, we kind of want to, go back into our topic from last week. And kind of what we were talking about and stuff like that. I know we kind of talked about some Revolutionized, type of stuff and stuff like that as far as, the learning STEM education, different ways of learning STEM. Mm-hmm. So, kind of want to get, your opinion there, John, since you weren't here last week. What are you thinking?
Yeah, I'll touch back again on this a little bit later too, because when you kind of go into what today's topic is, it's going to relate.
Yeah. Definitely.
So for me, I was listening to the episode, getting some of the ideas, and I like kind of where our head's at, as far as like saying, hey, we need to reevaluate what's important to us, especially in a world that's going more and more technology, more and more connectivity and things like that. So you have so many more people that are going to be able to consume the content or the information. And if we're focusing on a gathering place, the social part and the social aspect of humans makes sense. I mean, you always kind of want to build community and stuff like that. Makes sense to want to have a library in the community because you can kind of build around that. But taking it and switching kind of the ideology around like a localized high school. Yes, you'll have to rethink things like the sports teams and scholastic clubs, and if you have debate things like that or any groups. But like at the end of the day, if those are part of your community as opposed to a requirement. Most people view school as like a requirement. Mm-hmm. So you would do two things. You would funnel out the people that are like, hey, that doesn't seem fun to me, but I could still learn to get my trade to work on my car or to work on, anything in the industry, become a maintenance technician or even go into construction on that side of the house. Mm-hmm. You can make that decision very early on. And then if you have, let's say, some of the kids that take to the STEM learning that we're talking about and start having a lot of fun with it. I mean, I enjoy the gamification idea because it's something that you build, you make it fun. Yeah, and if you can find the passion and make the topic of learning fun to the kids, like that makes it that certifies that as like it's a part of them now. It's not something that they need to motivate themselves to do. It's something they unknowingly are doing. Like, I don't know, we look at it all the time. Yeah. Every single day we have 7, 8, 9, 10 different articles. We're like, hey man, did you see this? You showed me something literally 20 minutes ago about dielectric resin. Like, that's something like
we're always tinkering. Exactly.
That's something that like I didn't know that was there, but I know that it's what capacitors are made out of, so you can print capacitors. So these are things that it starts the line of questioning, but we've talked about it before, trying to get to that point earlier. Determine if that kid wants to even do this. Why should we force anybody to do anything they don't want to do? Granted, you should do something, so you got to find your niche or something like that. But at the end of the day, if you feel like STEM, that technology aspect of it is your thing, having that taking away from building a school, like you can have the gym and stuff like that, but make it part of your community as opposed to that school, that district, that county specifically owning, upkeeping. You have school administrators. You can make these. You can make this a at home job and have that person say control your staff and your payroll systems for any of the teachers or any of the programs, and not require a location. Like you could sign up for things and go experience the society and the community, but not force everything onto everyone. I think you save so much money, because we looked at even just a small building when I was in high school that they built. Like the parents had to get together and did a booster club, and everyone worked together. They built a clubhouse for the baseball team, and the kids, like we were there after practice hanging out. Like the parents were hanging out with other parents. It made community. So those things are needed. But if we're spending all of the money we have to make a physical classroom, as opposed to give a couple kids some Chromebooks or something even more, maybe a bit more technology maybe more CPU intensive, maybe a little bit more than we usually give them, and make their home the classroom. That would save. That would you redistribute the funds is what I'm saying. So that's I can kind of see how what you mean there. The one caveat I would have is it is tougher to make if it is a single family to make that family or that parent is the breadwinner have to go to work 40 hours a week. They can't sit at home and help train or help even coach or help even like so you lose some of that oversight on the if the kid doesn't have the motivation or something like that. I think that can be taken on a case by case basis, but it's part of temptation. Like we all struggled growing up, but not in the same way. And that built us into who we are. We shouldn't have to struggle the same way over and over, no. But when we innovate, we find new struggles and we find new ways to get around those things. So we create a problem solver, a critical thinker. So that's kind of I can see why it makes sense to redistribute the funds, give the kids the tools they need to succeed. Don't take away the social part and the community part. Like build that still, but don't force that connected with their education. So I shouldn't have to feel like I need to fit in to be able to learn, right? I should be able to learn on my own if need be. But if I want to fit in with everyone and I want to learn, that should still also be allowed. So that's the kind of the sense there because I don't want to alienate a teen or a kid or anybody that they're still developing their brains, they're still developing who they want to be or what they like. We want to show them all the opportunities and give them all the chances.
Well, universities have, both online and,
in-person education. So, and it's grown.
The ability. Yeah.
It's grown quite a bit, especially, COVID, like it changed the world in a lot of different ways, but it showed us that we could do this. Yeah. We could do online learning. Yes, it's a little bit less. It's not what we're used to. And they did do some tests and they lost a little bit of the standardized test scores, but did we lose actually the knowledge? No, we still know the things. We're learning a new method to we're retraining our brains pretty much.
And there's some people that they have to be in a classroom. They prefer to be in a classroom environment and learn paper and
exam dumps or like you just sit in, you have a boot camp. There's a lot of these things work.
I would even argue for a single parent because I don't have the physical school now. I have a library. Yeah. Now the library has all kind of tools, and I can have volunteers help at the library, and the kids. Now we got transportation that the kid can be picked up and dropped off, and that kid can be under the supervision of those teachers. So we take the teachers from a building where we were babysitting, and move those into those learning centers. So we make libraries learning centers.
And I can see that.
And to even piggyback on that, you're redistributing your resources because you could make that trainer or that person who wants to help lead their team. I'm thinking of like a magic school bus type of scenario where this teacher is like, okay, I'm gonna come get you. We're gonna have fun with this. Yes, it is a lot on that teacher, but if you make it to like each one of these communities in and of themselves are kind of doing these things, what ends up developing is you have a support structure for the kids. You're able to even maybe pay the teachers a little bit more and make it make sense to them because right now that's part of the problem as sad as it is to say, No Kid Left Behind kind of did hurt us a little bit because you start lowering the bar so much. Instead of saying, okay, maybe this isn't for you, we need to try something new. Maybe you don't learn that way. Maybe we can just show you some robotics and you can build some things like that.
Teach innovation is what it stopped. Teachers are no longer able to innovate anymore. But the thing is, I still believe that there should be no child left behind.
I'm not saying that.
I believe that we need to start innovating a little bit more.
You just
change the way you teach them.
Exactly.
And before we go down the rabbit hole any further. I believe you can identify something that everybody can do. As simple as that. And I'm not talking about doing some type of test to measure what your IQ is, because in my opinion, that has no bearing on what a person can do in a certain application.
There's a lot more factors than just
maybe a guy has an IQ of 250, but he can't paint.
Right.
Maybe a guy has an
Yeah,
IQ.
poor motor control. It can't. Yeah, it can't
Right.
put it.
So,
It can't
I
put
mean,
the words on
IQ is
paper or
different.
something.
Exactly.
Yeah.
And that's kind of before we jump into this week's topic, we talked also last week about repetitism and the prison reforms and stuff like that. We also talked about reforming the special education system.
Did you say prison reform?
Yeah, prison reform, educational reform.
Yeah, I was gonna say because
It's also called repetitism because you don't want people to go back.
yeah, well, and that's no, that's the thing.
And the thing is something else we talked about was because you have dealt with it and I've dealt with it.
Autism.
Is on the autism structure, on the autism spectrum.
Yeah.
But the thing is I really think that we need to really rethink that idea. Because the thing is every kid is capable of learning something. I think outing them and putting them in a special class and calling it special education is complete and utter BS. Because these kids are still smart. And the thing is don't make them feel outside because they're not with their friends.
You label them too early, and it does
Right. Let them enjoy time with their friends. They may have to just learn, and this is where we go back to no kid left behind crap, and we start dealing with the fact that we don't teach us who are allowed to innovate anymore. If you could let teachers innovate and teach these kids how they're supposed to learn, these kids, especially the one on the spectrum, they're smart and they learn real quick. But the thing is, they may need a little bit more hand holding. But the thing is, most kids do. And take them out of the label of being special education, and let them be a kid. Yeah. That's the one thing that drives me nuts is you don't let kids be kids. You don't let kids learn the way the kids need to learn. We're too busy labeling kids. Oh, you have ADD, you have ADHD. Oh, you're autistic. You're this. You're that. You're this. You're that. No, stop that crap. Yeah. And let kids learn as kids.
Yeah, I mean, those things may be you may actually have some type of a disease or some type of virus or some type of like disability in some way. That may very well be the truth, but you're right. Labeling from an early age creates this weird. You kind of ostracize them, and you're like, hey, you're not normal. When that's not really the way that you should view it. Exactly right. Like they don't learn the same way you do. It makes them special in the sense that they could probably do things that you can as well.
Right. Exactly.
So like I mean, my nephew, from a very he's a runner. He was like from a very early age. He knew his motor skills developed so much quicker than his communication skills that he was running around in a circle and like you knew he was having fun because he's laughing and giggling with you. Yeah. So he learned like he's making those games and you're playing a game with him immediately and and without even being able to communicate that he's able to think that through and kind of connect those dots. So they're absolutely.
That's what we do. That's what we deal with too.
Yeah, I mean, and even nowadays, I hear him with my brother, and he just says, "Use your words." And yeah, he'll struggle a little bit, but it only takes like use your words once or twice, and boom, he's got a full sentence out. He says, "Okay, it's like a passphrase. You need me to say this for me to get that toy, or for me to get what I'm wanting," and you create that like path to like the stimulus that they're looking for.
Yeah.
So
and tie it to things.
Yeah.
My nephew loves, good Lord, loves Thomas the Train.
Yeah.
If you can gamify freaking stuff for those kids, using like Thomas the Train and now I think it's also Buzz Lightyear. Yeah. They'll learn and they'll learn quick. Yeah. And that type of stuff. But now that we can kind of shy, I guess, away from.
Yeah, I mean,
we talked about this all night.
Yeah. And the topic needs some time too.
Yeah. So this week we kind of want to dive into a topic that is kind of interesting. It's deals with innovation. It deals with 3D printer innovation, but it also supports the increase in the housing market. Well, not really increase in the housing market. But it really helps reduce the amount of homelessness you have. If you think about it, it's really the only type of printer that can handle, the changing of or supporting the rise of a third world country. Mm. So I think about it. What we're talking about here is concrete 3D printers. We have some of these companies out there who are making these concrete 3D printers. They're printing tiny homes in 3.5 hours. Good Lord. You got people who can't even lay brick in 3.5 hours, but let alone you got this machine that can print the foundation or the walls of a tiny home in roughly like 3.5 hours. If you think about it, the thing is yes, they're fire retardant because it's concrete for the most part. The shear volume, I think they're testing the shear volume now. I don't know if they fully got that down pat, but I know they do. You have companies like Lennar that's diving into these concrete 3D printers hand fold. But they're also one of the very few printers that we can bring to a developing country that has an issue with homelessness, and you can build out those tiny homes for people. You give people a place where guess what, they have 4 walls, a door, and a freaking roof. They may not have much, but they have something that's theirs instead of a hut or a tent that they have to live in because their government gave up on them. You got, so, when we start talking about 3D printers, it's actually a device and piece of equipment, not just for additive manufacturing, but also for the construction world, but also humanitarian, if you think about it. It's one of the very few things that the additive manufacturing development, companies that came out with that, I actually look at and think that this can be something for good. It's one of those few things that I look at. So, with that, what do y'all think?
Well, I mean, I think it also could probably be used for, applications where we use civil engineering also.
Mm-hmm.
It depends.
You mean like infrastructure you're talking about?
Yeah, like infrastructure, like up north we use concrete for some of the roadways. Maybe some things.
Built bridges and stuff like that. Yeah.
Some portions of the bridge because bridges are built in sections. They're not normally poured as one pour.
Right.
We used to many years ago with dams, but even with the dams, we would pour so much it would cure, and we would keep pouring and pouring and pouring. Hoover Dam, I think.
Yeah, Hoover Dam is
an
like
example,
that. Yeah.
And I think that takes many years to actually solidify. But I think, say, maybe in some areas that are remote that we need to get to, maybe this is something that you can take and start that, and you don't have to have the same amount of manpower. Not necessarily the same humanitarian, but I think utilitarian is good also.
Yeah. Yeah, I mean, on both sides, it makes sense. To me, you could take it. I mean, we always want to go towards like better in mankind, or the for community or for society, humanity. But at the end of the day, it doesn't have to just stop there. I mean,
right.
Once we kind of established we were gonna like do this episode. I even thought about this. It's like I've been looking at concrete printing for a couple years now, and ever since I first saw it, like the concept of it made so much sense. I do have questions on, is it earthquake proof? Is it storm proof? Stuff like that. Yeah. But at the end of the day, is the start of the whole process is I'm building with concrete without having to set up a jig and a whole bunch of pieces of wood and line everything up. I'm using a certain, now this gets into chemistry, I'm using a certain composition of the concrete to make my structure solidify in such a way. And then I started doing more research because they were building like a community, a whole like neighborhood.
Yeah, Lennar is the one behind that.
And that was in, what was it, in New Mexico or not New Zealand, New Mexico or like Utah or something like that. But
that makes sense because Arizona, they do the adobe houses.
Yeah. So
hopefully they pour more square than they built this house. Lennar's doing it.
Yeah. Well, I mean that's the thing is that like construction and new constructions, like especially because when I went through and I was buying my house, I looked at new constructions, I looked at existing constructions, I looked at so many different like foundational issues, and I was like, man, all of this kind of, I need to learn about concrete and learn how this works, or what can I expect, how can I prevent some issues, or if I buy into a house that has existing issues, how do I fix those without tearing my house down? So that's where it really started. Then you can see that in a lot of these new constructions, they cut corners.
Oh yeah,
They cut a lot of corners, and if they can trick you and the inspector into thinking that this is fundamentally like perfect or the right way or the most efficient way, they will. They will try to cover up a lot of the things, and that's not. I'm not saying that should be on the company itself. Usually, it's the workers or whoever is running that construction site. But at the end of the day, it's with the standards.
Right. But it is the company's. It's the company's duty to understand what quality is being promoted for their company, and it's the person's craftsmanship that also is responsible.
And the thing is even with the 3D printers, they're not. If you actually look at the houses when they're built, they're not terrible. I mean, they look good.
Exactly.
They look, and the thing is, you can put a window in no matter whenever you want. It's going to pour around that window. It's like, I guess you could say, a modified quick freaking G code. And that's what it is. And like, I've looked at some of the stuff. One of the manufacturers actually published, hey, this is the granules that you can use and stuff like that. Yeah. It's really not that bad. You can actually get it from anywhere. So they're not a specialty concrete you're having to use to pump through these machines, which is great, by the way.
Yeah.
And the thing is, you have them in different sizes. Like right now, I think they're using them in the war in Ukraine because they were printing the roadblocks, the stanchions.
Yeah.
And the tank stoppers when they were heading towards Kiev. So yeah, they're used in other areas. I think we were talking about doing a storage shed with a 3D printer because it's easier and simpler and quicker.
See, that's what I was getting at when I was saying. So you build the house with the standard conventions, and it's this amount of money, and probably a dozen workers. You need framers, you need electricians, you need all those things. And yes, if you 3D print one, you're going to need at least one of those guys to make sure. Maybe not framing as much, or unless you're doing a roof, so maybe you do need them. But at the end of the day, it's you take a job that's 12 or 15 people and you put it to 6 to 8 people, and it's going to be done in half the time. Yes, the concrete has to cure, but you're absolutely right. It's quicker. There's less work to be done, and honestly, you can take the amount that you're saving from not paying those extra workers. You could pay these guys, the ones that are actually running the equipment, a little bit more, and then the company will pocket a little bit more profit. I mean, it just makes more sense because they're lowering the quality because of where they make the most money off of it. But if you take and you make them, okay, you're going to make this cheaper, you don't have to worry about that. You kind of bring that bell curve a little bit higher for them.
And I think when I was looking at the documentation on it, they require a 16-foot trailer, 16-foot enclosed trailer to haul. And I think it's 3 people, 3 hours to set up. And that's it. The only thing you have to make, and then the only thing you need left is to make sure you have a pad port. That's the only prep you have, is make sure you have a pad port and all your utilities are in place.
Yeah.
I would say just another application that maybe that could be used to also is to make wave breakers.
Yeah.
Where we have we have water rising, or we have natural, when we have storms, the water table rise, or we just have natural rising because we're below the sea level. Yeah. I think that would be something that a city could invest in, make these wave breakers ahead of time, and then they just have to have some heavy equipment to put those things in place wherever,
right.
And you can be creative. They don't have to be like something that's hard to look at. You could make it into a sculpture type of thing, or maybe a person wants a sculpture. Yeah. You can even use that application to make a sculpture with this type of thing, or maybe we can even look at it for making basketball courts for low income areas for kids to have something to do, because you would reduce the cost, and it doesn't have to be totally level. It just has to be level enough that they can play, but it's better than playing in dirt.
Right. Yeah. Now, I'm gonna throw this zinger out there. What if we take a 3D printer, not a 3D printer, but a 3D concrete printer, concrete 3D printer. Wow, English. And stick it on a Falcon Heavy and launch the damn thing to Mars.
Okay, so you're getting to where I was gonna go.
You can, but I don't think right now they have.
You don't have people there. So
no, not the people part. I think you can use. We have the potential with the advancement in robotics, that's not a problem.
Yeah.
I think the problem is do we have the technology in place for the environment that we have to put it in?
Okay.
That's what I'll be
So
curious.
so
Like
so
the granules
yes.
and stuff like that.
So yes. Okay. So I was actually really excited because when I found this article, so we talked about wanting to go to Penn State for the additive manufacturing program.
Yeah.
I looked up some of the professors. Oh man, his name escapes me right now, but he has a program where and he's an electrical engineer, design engineer, and he's made small sats and stuff like that. Objects, he's like created them so that they will like kind of live in space, microgravity, all that good stuff. But he recently, when he moved, so he did go to school, undergrad Penn State, graduate at Michigan. And he didn't really like saying that. Then he came back and he's a professor at Penn State.
That makes more sense.
So
So he had to go to Michigan and become a
yeah,
professor?
we're gonna leave that where it's at. Yeah, he's like, he didn't want to say the name. He didn't even say the name. He said that school up north. I don't want to say. Y'all
Okay,
play him
let's keep
sometimes
going.
on
Let's go.
Saturdays.
As long as he doesn't say Ohio State, I think everybody's okay.
But yeah, so he was talking about he's got a new like small business, and there's these grants, like research grants that you can get for small businesses that NASA or the government provides. And what they were doing is that he had like one of his colleagues said something about, man, I want to print like in space. Like, can we do something like, what about it was at around the same time that NASA had their challenge, the Mars Habitat Challenge. So they challenged a lot of companies, a lot of research groups to say, hey, we've got XYZ stipulations. We need you to try to make a machine that can make a viable structure on the Martian planet. Here's like the soil compositions, and then they pretty much said, here's the details, have fun, make me something, right? And I don't think that they won the whole thing, but they won a lot of you had like tests, or like they're like, okay, this is structural test, blah blah blah. Hey, this is a test to see if your materials will be made. I think one of the best like method that they tested was using what is the binding agent? How can I if I use the dirt or dust that's on Mars, how do I make concrete bind together?
Right.
And the answer that they were trying to do is use microwaves, and so they can use microwaves so the dirt or whatever itself becomes the binding agent.
Compact.
You change kind of the structure, the chemical structure of it, to where now it's going to solidify in such a way that it makes you a structure. So they took that. They didn't win it completely. It's hard to do. That's a very complex kind of problem. Yeah, I mean, and nobody's lived over there, so how do you know for certain? But they took that, and now they're working on lunar habitat building, and the dust and stuff like that on the moon, regolith is called.
Yeah.
They're using that with the microwaves, and it becomes a binding agent. They pull there's like a little bit of humidity that they're getting through there too. So like honestly, this professor is kind of leading the field in concrete printing in space and microgravity with a few others. It's kind of like a group of professors. It's not just one man. I mean, he's the one I learned it from. But at the end of the day, that's where, because we were talking about education. Like college is one of the best places, one of the first places. You know, a lot of the youth nowadays would learn about some of the bleeding edge of technology, the bleeding edge of research, like where are we at right now as a society and things like that. But you if you start early with the STEM, build them up, then this sounds incredibly complex and complicated for some of us. But if you get the kid going to his undergrad the first time, and you teach this to him the first time, and you've already built that knowledge or that passion behind it, they're building lunar habitats. Yeah. We talked to somebody at Rapid.
Yep.
I think they were based out of Indiana, Rutherford.
Rutherford. Yeah, right near Purdue, actually.
They won the coolest thing in Illinois because they were building lunar structures as well. So for me, like
lunar structures on this planet or lunar structures
it was on this planet.
So I would say this: The microwave, I can see that working.
They're just trying stuff. It's the
No, no, no,
intersection
no.
of disciplines.
No,
Yeah, it's good though.
The physics,
it's good. Yeah,
the physics is good.
yeah.
My question is, okay, we have material,
Mm-hmm.
we have a physics concept.
Yeah.
How do we get the power to produce microwaves? Microwaves take a lot of power to generate.
Yeah. That's the problem. So that's the problem that they're facing now.
It can be done
Yeah.
because we do it here
Yeah.
with portable things. I'm just curious, what's the next innovation in power distribution?
You start
Exactly.
thinking like nuclear
Yeah.
decay and stuff like that.
Well,
like
it's probably going to be
half-life.
some form of nuclear. Yeah, because that's the problem that humanity as a whole is going to have to solve, no matter if it's concrete printing, aeronautics, anything like that. The problem that we have as a society is we cannot make enough energy, and we're constantly trying to figure out how to make more energy or make more efficient energy.
No. I think, like you said, it's the same thing. Whether you're making it efficient or not efficient, it's still you have to make enough of it.
But they're doing
Those
the
are the-
microwaves
Yeah.
because they can't do thermal. They can't just
Right.
heat something up like that. So they introduce the microwaves and
But it makes sense.
But you still got to
Right.
do work to the system.
I mean,
so
the microwave makes sense, but I don't know. Just thinking outside the box,
yeah,
there is microwaves exist also outside of our planet.
yeah,
Is there a way to harness these things?
yeah. No,
Well, you're
exactly.
dealing
Like
with-
radiation, because
Right, you're dealing with a moon that does not have an atmosphere.
yeah,
What I mean, but that in space,
it's got less of our atmosphere.
I
so
guess
yeah.
in space, what I mean is, I'm saying in our atmosphere,
Right.
we have, we generate microwave, but microwave exists. Microwave also exists in space.
Yep.
Right.
So what I'm saying is in space, whether you have an atmosphere or not, is it possible the same way we do with sunlight? We develop
Like sensors,
devices
yeah.
that can convert that energy. Is it a way to make some device instead of sunlight, it can take microwave and create energy?
Yeah, honestly, I think that there's something like that, like taking some type of radiation in, and I mean,
Curious. I mean,
like-
it's some smart guy somewhere that probably will say, "Yeah, we already got that."
I mean, we do have to figure it out.
Yeah.
To me, what's probably going to be, and I know it's just an emerging technology now, but what's probably going to be our form of energy in the future is going to be fusion. It's about creating more energy than you put into the system. Therefore, you get to a certain point where you can make as much energy as you want. However, it's very dangerous. I mean, fusion is what the sun does. Like nobody wants to be
Right.
in the sun when it's doing that, but it's so much energy.
Yeah, I think, and before we get too far off topic, I think the problem with people in energy, they want to do what's easy. The problem with people with energy is, well, physics say blah, blah, blah. The physics say that. Because Newton physics is not Einstein physics.
No.
And Einstein physics is not the next guy's physics.
Yeah.
Because Tesla, whether anybody want to believe it or not, or debate it, you could take energy out of the atmosphere on this planet. And from taking it out of that atmosphere, if you knew the resonant frequency of the earth, then you could direct that energy without wires.
Yeah.
Yeah.
I mean, you're using you because
According,
And of course, we don't want to
according
get too
to
deep.
His,
Well,
his experiments.
electromagnetism,
Yeah.
electricity and magnetism are tied in such a way that one wave induces the other wave. So if you're using the Earth's magnetic field, then I can see that happening. Yeah, I mean, it's going to take a bit.
According to his
it's going to take a
experiments,
big
I
magnet.
have-
The Earth is huge.
Right. But the Earth is a big magnet.
Yeah, exactly.
If
That's,
you understand how to use it.
yeah, exactly.
Well,
And-
let's not magnetize two planets and then we're going to clack them together.
But then one other
Hopefully
thing,
that's what
one
we're
other thing,
doing.
and then we're gonna move.
Yeah.
There is more energy in a lightning bolt. In one lightning bolt,
Yeah.
if you can ever figure out how to harness that, and take that same energy that you're trying to do with light or wind.
I have a joke on that one,
You know,
but I'm going to keep it.
No,
Something about Ben
it's
Franklin?
actually in Florida.
coach.
I forgot exactly where in Florida. There was actually an experiment done where they had capacitor banks in the ground, and they were attempting to
What was one
harness
lightning
this
bolt?
energy. I mean, of course, it didn't work. They haven't quite figured out how to deal with that amount of energy.
Yeah.
Yeah.
But if you could harness one bolt of lightning that is a tremendous amount of power.
Yeah.
Especially if I'm going to use it as like a charge.
Yeah.
But anyway, let's go to the
There's
first.
probably a few people that have harnessed that power but haven't walked away from it. You know, they harness the power already.
As man has been struck twice and lived.
Yeah. In the same spot, ironically.
Don't.
Let's keep going.
I won't. I'm not going to volunteer for this experiment.
No, he literally 1 in a million got hit by lightning twice.
In the same location.
No thanks. I would never go back there. Never go back.
But
there.
let's get back. I'm sorry for taking it down.
But yeah, but okay. So where we started was talking about in space, like 3D
building
in space.
building.
So the guy that we met at Rapid, they were building things not structurally, just they were building things because when you think about a spaceship, I like think about the space station. When you look at the inside of it, a whole bunch of buttons, whole bunch of valves, whole bunch of wires, whole bunch of there's too much going on there. So they were thinking about they were thinking about your mentality,
How to get rid of the sensory overload.
building sensory overload, building something in space that's more soothing or acceptable for you as an astronaut that's living on a planet that wants to kill you. That like the moon does not want you to survive. Mars does not want you to survive. So you're already kind of in a situation where it's like, it's looking pretty bleak. So they don't want you. They want to do as much as they can to ease anxiety and soothe you. And that was kind of their idea because they weren't using concrete 3D printing.
No,
it was like nylon or a carbon fiber.
It's like a
or
nylon
something like
fiber
that.
board and stuff
Yeah.
like that.
So that but their idea was
It's printed with a robot.
It goes over or covers the wire because you still need the wires. You still need those connections. It covers everything in panels so that you can have a structure that feels more like a home as opposed to a spaceship.
Yeah, and it's printed 100% by Kuka KRC4.
Yeah. So Kukas, all the robotics. What is it?
They all could do that. Google
Yeah,
just got the contract.
Yes. So that's
Well, the thing is, they
It's
probably
not
found
this-
them cheap enough because everybody's using
Well,
them,
I'm
so they found them on
saying
eBay.
There's no robot that does not function like another robot when we talk in motion.
No,
None.
yeah, because
Period.
they're all 6
Yeah.
degrees, six
Yeah.
all.
Yeah.
But so the idea of building with one of those robots is, I mean, we have the Cartesian prints, we have Delta printing. So there's different ways that we have tabletop printing. Those things can still be used in a concrete, like a sized up fashion. I'm assuming more of a Delta printer would probably be best for you in a lot of situations because of the variability. Variability. That was hard enough to say. But yeah, so you can change it so often that to me you put wheels on the sides of the Delta printer and you can move it around.
And if you think about it, if you remember the printer that we saw at Rapid, that was literally printing the chairs for their own exhibit, right? You add concrete to that mess, and you can literally print, patio furniture.
Yeah.
Heavy patio furniture, but I guarantee you, guess what it's not going to do? It's not going to get blown away in the middle of the afternoon.
Maybe not. Maybe you can figure out the composition and the flow rate.
They do have a styrofoam reinforced concrete that's not as heavy. However, that's when you start dealing with melt temperatures and all the other fun crap.
Yeah, I'm just curious if you can
that's
play with flow rates or something like that.
You absolutely can.
Or the injection of styrofoam or something like that.
Yeah, I'm just curious.
But it's like if you think about it, you could get one of those things and you just literally print, pool furniture. Being from Florida, I deal with the couple things a year where we just get pressure washed.
Yeah.
And a lot of people get sick and tired of having to throw their stuff into the pool.
Yeah.
Or put it inside the garage. Because we're getting ready to get smacked by Mother Nature's PMS or better known as a hurricane. But if you 3D print the damn things out of concrete, guess where they're not going?
Yeah. And what else goes with the pool furniture? The pool.
Yeah.
That could be a very profitable business to somebody.
Like an above ground pool.
Yeah. Well, no, you can even do it in ground.
Yeah.
Because you got the printer, you'd
have to prep the area first.
Yeah.
Yeah, you probably, unless I can control the flow rate. If I can control the the viscosity, then it holds itself up. And if it cures because of the composition of that material at a certain rate, and I just keep building layers, once I do the bottom, the rest just goes up.
Well, no, that's true. I'm just saying you have to
dig
the hole.
But you still got
to prep the surface. You're going to
you still have to prep
Yeah.
going up the side because
You don't want it to fall.
Yeah.
You want it to be the right
Well, even
slope.
in the houses, the thing is, if you 3D print it, like when they're 3D printing like houses and stuff like that with these 3D printers, you do no framing on the sidewalls. It does it all for you.
Yeah, but
You can though,
But
and that's
yeah.
the beauty. You could drill it right. You could put
Right.
you can put sidewall up to where people don't realize that
No,
it's
yeah.
a 3D printed house. You can make it look the same.
But I mean, you don't need to do forming.
What
So
is
there's no
it?
forming
okay.
needed.
Okay.
what's the
yeah.
geometry? Is it a square or is it a dome?
It's the thing is, it's square right now. They
You could do
they haven't started doing the roofing yet.
Because you bring in the roof or something
Right,
like
you
that.
bring the roof
You
in.
But
pay
that
for the
makes-
resources.
that makes sense
So
anyway.
you would
So-
build it and it would be flat right now. I mean, I think you can do domes though.
Yeah.
Because
Yeah,
I've
you
seen
definitely try.
I've seen some structures. I think there's one around where I grew up that was not 3D printed, but
Mm-hmm.
the structure it's all concrete. So it was like a concrete dome of some type, and I don't think that's difficult to do.
Yeah. Could you imagine if you had to put supports in that damn thing?
But
Yeah, right.
here's the
Just a couple guys like I hope this doesn't fall, holding it up.
here's a caveat about them not doing the roofs. You do not want the roof fixed.
Yeah.
You want the roof to have some flexing. That's why when they do the roof with the framing, it has some flex in it. It has strength built in it the way you build
Right.
the members, but also they screw it down. But there is some,
Using lag bolts and shit.
and you also have to have airflow
Yeah.
go through the house so the house can breathe also.
Yeah.
And
Otherwise,
yeah,
it'll be too much stress. It'll
moisture.
break.
Yeah.
And say in a southern or southwest or Texas, you probably have some problems.
It would be next to terrible in Tornado Alley because it would take everything
Yeah,
with it at
'cause
that point.
It would catch in
Yeah.
Yeah.
I mean,
Well,
but you think,
would it?
but you,
the weight. It would have to be a direct hit.
it would
Yeah,
have
literally.
to be a direct hit to take because it is
You
heavier
just
now.
came up with something. You could probably make tornado tolerant or tornado resistant home.
Well, as long as I wouldn't think if you
I'm
print the
saying
entire
wind, just from the wind.
right.
Not
But the thing is,
tornado.
I don't think printing the entire roof it would
Well, I
be
just mean
beneficial.
the structure. You
Yeah,
still
but
have
no,
to
but I
can
mean,
build it,
you know,
you can
when
have
you
it
start
cut the
getting
wind
into
too. Yeah.
as you're coming up your walls, you start getting into your awnings, not where you're the under bottom of the roof, so you mount into there, and then so there's no way air can get up
Well,
inside.
you
It's just fine.
take the concept of a spoiler.
Yeah.
The spoiler's pushing your car to
Yeah.
the ground, and if you could build it in such a way, now I know it's hard to predict which direction the wind's coming from, but if you have something that's adjustable, then you direct it where the wind's at, it'll
Next
stick
thing
you
we'll
to
put
the
under
ground.
on houses too.
Yeah.
That's a good idea too because there are vents that you have, that go around. Maybe not these because they have slabs,
Yeah.
but like some of the block homes,
Yeah.
they have vents that you have to go open, or you can get the ones that
The auto open.
the by metallic
Yeah.
material, and when it heats up, it expands or contracts,
So it opens a
and it
little bit.
opens and closes.
Yeah, I mean that makes sense. See, but that's the concept. So like I think about this. What's the use of the spoiler to keep you to the ground so you don't fly
Yeah.
away? I mean, why not?
Yeah, I mean
use
that's
something similar.
That, you
And,
could probably do something.
You know,
like
if you think about it, a lot of times, and this is where it gets into like sustainability with these things. I've had more friends lose their houses because of the fact of flood damage. I've had 5 or 6 friends that they've lost 15, 20 years of marriage
What here in
in Florida
Okay.
because
We live in a
they had to tear their house down because
Here too.
yeah, here we live in a swamp here.
But because of something that they couldn't control because
Yeah.
of flooding.
Yeah.
It's like okay, cool, but the thing is they had to tear the entire structure down and restart. The thing, and so if you 3D print a structure, one, if it's flame retardant or mold resistant, now you don't have to worry about that anymore. Yeah, cool. If it's on fire, then of course you got to replace your roof. And then guess what? Your frame's still there. Done.
Yeah.
Start back over again.
However, when concrete's heated,
Right.
you change the composition of the concrete, and it could become brittle.
Right.
Yeah.
And the thing is that's where you go back and you test it, you see what it is. But the thing is, if you make a concrete that's capable of handling certain degrees for a certain amount of time,
Yeah,
There are
special
caveats.
mixes.
right?
There are
you,
mixes.
you start getting into that type of
It's
stuff.
incinerators.
Yeah, right.
Yeah.
I mean, there's a lot of stuff you have to think about with chemical reactions.
I still
too.
wonder if that gets too brittle though for a house though.
Well, but that's the thing is like so my sidewalk at my last place I lived at when I was renting down there that duplex.
Yeah, yeah.
So the when I put the pressure washer on, I realized that a lot of the roofing on the top of the house was coming down, and I was like, oh, this isn't the color of asphalt. This is actually concrete. So I started cleaning it off. But then you realize this has been here maybe 10, 12 years, and that concrete is degrading. So there is one thing that you have to think about as far as what the chemical consistency of that concrete is that you're making. Is that house going to last 10, 12, 20, 30, 40 years, or is it just going to last 5?
Yeah.
If hit with constant rain like we are here, then that would be a question I would need to answer. And the answer to that question is almost immediately. We said a few minutes ago is you can put the siding up, you can put things that'll protect it. You can have the same way we do with wood, where we put like a treatment on it. We can do the same thing for concrete.
Well, they make zip seal. I don't know if you've ever seen zip seal.
Okay.
It's made to.
So you just put an outside coating.
So
Then
if you build a concrete wall, you basically you do it.
It's the same thing. It's pretty much the same stuff I told you put in your garage.
Yeah, you put.
okay, yeah.
You put these boards up.
That's on your walls.
Or you put this. They get 2 ways.
Yeah.
If you put the boards up, it has a way to seal.
Yeah.
But they also have a vapor barrier.
Okay.
That goes over.
Yeah, it's like a liquid vapor barrier.
That makes sense.
No,
though.
it's too. You can treat it, but then you can put a plastic barrier over it. But when you put this adhesive, it basically you roll it on there.
Okay.
Then you put whatever other sheathing on top of that.
Right.
But for
kind of like you prime it, right? Yeah.
For flooding, if we have the 3D printer that's using concrete technology, you know, where we're able to 3D print with concrete, then why not build?
It's like kills.
Well, yeah. Well, it's similar. Well, why not build drains
Crylock.
that divert the water away from the house?
Yeah.
Why not solve the problem?
Yeah.
Try
I put
to-
a French drain in.
What
need to do one
at
of
what
those too.
rate?
Yep, you do.
If the river overflow,
Yeah.
what rate do I need to move the water away from the house before the ground becomes
Before I
saturated?
start or before I start getting damaged or
And,
something.
you know,
like that.
it might be something fun for us to kind of dig into one of these days. Is kind of really focus on this topic, maybe in a video or something like that. It's for this thing, but for the 3D printing side of the house for concrete. Because if you think about it, most companies invest. For example, I know we did it in the government when I worked there. Is environmental testing. They do a small scale. Setup. We used to stick an entire server rack in there and watch it blow to pieces. It was hilarious. You spray water on it. You drop it from a certain altitude. Yeah. You shake the living heck out of it.
Yeah,
right.
Yeah.
And the thing is, you pretty much watch it crumble. Or in my case, you shoot hard drives for as far as the eye could see. Which is always fun to watch. But the thing is how much of this stuff has actually gone through environmental testing in real world environment. At least in a non-controlled way. Because cool, I could test this thing in Nevada. Y'all, Nevada has 2 seasons: hot or hotter. And then
Right.
and it's like Utah. You have cold or colder. Pick one. And it's nice during the summer for the 3 days that you actually have a summertime. Then it goes back to being cold again. Really? Bring it down to Florida where you get at least 2 seasons in a monsoon season.
You're guaranteed going through at least category 2, 3 hurricane.
Right.
And like I said, it's one other thing. If we just go back, I'm just going to, hey, how can you use this?
Yeah.
Where we can reduce costs. What about septic tanks?
Yeah.
Oh, seriously? Yeah.
What? Why couldn't we? Because we don't have to have the same amount of strength for a septic tank as I do for like a dam or say for a home. We have to meet some criteria that we don't get absorption through the concrete and it leaks. But other than those things, how much money could you save?
A lot.
Doing that, and could you make unique septic systems?
And that, I mean, honestly, at the end of the
Put them
day,
on top and then lower them down with a crane.
at the end of the day, it's about saving money because, and it's been over a decade since I've been to the Philippines, but when I was there, it wasn't like necessarily a first world. That wasn't necessarily a third world
No, but
like city, but it was definitely a culture shock. The builders, of course, there's no OSHA standards over there, so just a couple guys in a tree with a ladder tied to it, laying the bricks for the concrete and the cement and stuff like that. I think that it'll fix those problems. Those guys can get trained on how to use a 3D printer. They could build the neighborhood out, and then they can probably continue on for some other neighborhoods too. So it's for us, the technology exists, and we're developed as a country in such a way that we can start utilizing these things. But for the third country, like or for those countries that are a little bit less developed, this is a game changer.
Yeah.
This is infrastructure everywhere. Like we had to drive to get to the city where my mom's from, or the village my mom's from. It took a flight to Detroit. That's a 3-hour flight. It took another flight to Nagoya, which was like 11, 12, 13 hours. It took another flight from Nagoya, Japan to Cebu. It took another flight from Cebu to Bacolod, and then a 6-hour drive on a dirt roads to get to the city. So for me, just in pure infrastructure that you can build,
Oh yeah, it's insane.
you can take 2 or 3 flights out of that and have maybe a bit of a longer drive, but it wouldn't have to be on a dirt road.
Right.
Honestly, some of those roads were on the side of a mountain. It was pretty scary, and they were still trying to build the road, and it did not look the safest.
I'm glad that you got to see, where your mother's from.
Yeah.
But it is no freaking way I'm
sure?
ever gonna fly from this country to
Yeah.
that country.
Yeah.
No way.
Well, you can probably get a straight flight to Manila.
No
Yeah, you can go to Manila.
way.
You like Manila. Manila is like the most
I
developed.
didn't want to fly the time I had to fly to go to Germany.
And you're gonna go with us to Chicago and friggin' in May?
That's nothing. That is nothing. You know what I mean by long flights.
I've been on a few.
Yeah.
Oh, yeah,
They're
no,
okay for the first couple of
I
hours.
sleep the entire time, so I'm okay.
I watched like 4 movies.
Yeah, that got on too. Well, I was
It
gonna
does
say
get
I
old.
snore and people
It
think there's something wrong with the engine.
one other
That's
thing
good.
we didn't think about with the concrete printing is flower pots.
Yeah.
How much of the plastics could we keep out of the landfills?
Mm-hmm.
Because they get brittle over time, and just figure out a way to print
Yeah.
the same.
And if you do it in
Diameter.
such,
Yeah.
if you do it in like steps, because the issue I see with a lot of planting and farming is that they have to repot here, and that's why they have the quick like switch plastics
pots.
and stuff like that, spare pots, because you need to reset it into another place to let it grow more. You need to reset it to another place because it's not growing.
And you have to give the soil time to the nutrients.
Exactly.
And if you don't cycle those plants, like that's why they do the corn,
Yep.
the okra, and the tomato
Right.
from the Indians.
Yeah.
They knew to do that to cycle those plants through and to put them together because they work together.
Yeah.
But by cycling them through, then it didn't destroy the soil.
Exactly.
And
That's true.
and like what you said on the recycling part of the house, as far as the fact that concrete's recyclable. 100% concrete's recyclable.
You throw it back in.
Right. You grind it back up, spit it back out.
Yeah, right.
Guess what? So, but the thing is what that means is that, all these houses people are building, once their service life comes to a complete, after 30 plus years, as long as it's not contaminated with anything, absolutely insane, you're going to burn it out anyways, is now it's recyclable. The roof line's recyclable because it's all wood. The concrete itself is recyclable. So technically, you restart from scratch.
Yeah.
So, I definitely don't want to, think it, but you can always have a recycling program for your house. Hey, I want a bigger one. Let's go ahead and recycle this old one and rebuild a bigger one. And it'd be kind of a weird way of buying houses.
Recycle this and put a down payment on the next one.
Exactly. But the thing is, it's a plausible thing because people are always looking for housing.
Yeah.
So why not give them the ability to, hey, let me recycle this
Well,
old one and get a
look
new
at the
one.
housing market.
It's only take a couple hours.
Yeah.
We're having trouble with the housing market and things being so expensive now. This is just going to take the cost way down too.
Yep,
Yeah.
forest materials, yeah.
Yeah.
But one thing I would add, I would imagine, we're getting close.
A little bit.
I would imagine, like I said with the Hoover Dam, that you may actually have the opposite. That if you had the right composition, that those houses could probably last 100 years.
Yeah, I mean that's true.
If you had the right composition.
And there does need to be some maintenance, at least a little bit of checks and balance. This is why we talked about preventative maintenance checklists. So you should, if you're building something once and you expect it to last and you're not checking on it,
'Cause
you
it's gonna
don't, you
sell.
shouldn't expect it to last.
Every home is going to sell.
And you know,
It happens.
I believe these things were also. I got to look, but to what I've heard, they were actually shown at World of Concrete. The show that they just had in Vegas called World of Concrete, where
The
they
whole convention about concrete.
concrete and how it's formed and stuff like that. So I believe it was shown there also. So the thing is this stuff's revolutionary. It's coming, and I know we're kind of getting close on time here, where we're getting towards the end, and I just. I guess we'll call it now, but I know this is conversations keep coming back up again.
Yep.
Because concrete 3D printing is something that, not only supports the advancements of other nations, and it actually will take people from poverty to homeownership pretty quickly. Even if it's not their own home, if it's hey, we make them a tiny home, just something, a place to rest their head for them to be proud of themselves, so they can go ahead and move forward and do big things. But I want to, and who knows, I might dump into that my thesis. We'll see, or dissertation. We'll see. But the one thing I want to do is I want to say thank you. I want to say thank you to every single person who tunes in. We're at 2,224 all-time downloads, and I remember there for a little bit. We were happy when we hit 50. Happy when we hit 100. We're freaking ecstatic. So I want to take the time and say thank you to everybody. Go take a look at some of the stuff we're doing. We're getting really into some bigger and better things now. Everything's moving. I know the one thing we didn't announce today is the company itself, that hosts this podcast, Vulcanar Technology Solutions, is now officially a member of the SEMA organization. We'll start working with through the SEMA organization to support the advancement and the car customization in the automotive world. Little by little. A little bit of 3D scanning, a little bit of rapid prototyping, and a little bit of STEM education while teaching everybody how to do all the things. So go out there and take a look at that organization. Go take a look at the blog. Go take a look at Vulcanar 3D if you're looking for merch, or go take a look at Printed Heritage if you want some of the lithophanes and some other few things. We'll be adding more and more and more to that. I need to start doing some more flag lithophanes. I need to order some white PLA soon. But that's it for my side. I'm going to turn it over to the guys, and y'all have a good one.
I just like to say I appreciate the support. Thank you guys for tuning in. We are still, if you guys have any suggestions or if you have any ideas, we're still trying to figure out the logistics of maybe doing a live Q&A with you guys. Stay tuned to that. Once we get that worked out, we'll make an announcement. Maybe we'll just shoot from the hip and see where it goes.
Yeah. Same thing from my side. I'm always very grateful having this platform, having anybody that listens. If we can give anybody any information that's useful to them, it's good stuff for me. But yeah, no, take a peek at a few of the blog posts, the website. I would say look up SEMA if you don't know much about them. It's nice to learn about some of the. I mean, automotive is going to be an industry that's going to be around for much longer than we are. So we should take a peek at it. There's always applications of 3D printing in so many different fields. It makes sense in some of the automotive world too for some of these non functional or even just aesthetic pieces. So and rapid prototyping just means that I can make sure it fits that much quicker. So if you're interested in cars or anything like that, SEMA is a good place to start and kind of look at and learn some of the things. They have a show in Vegas this year. You could probably see some things going on over there. So, but yeah, as far as the rest of it goes, if there's anything that was confusing or interesting to you, go ahead and do a quick Google. Don't believe everything you read on the internet because anybody can just post it. But it all starts from ideas, and if you learn from that and grow from that, then you're in a good place. So read what you find with a grain of salt, but always keep learning and looking for something new.
All right, go.
Thanks, guys.
Have a good one. All right, bye.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. and join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.